Hello and good morning, everyone. It is great to see so many people have taken out their time to come here and come online and attend this wonderful webinar. We promise you a great experience. About me, I am Abhijit from Analytics India magazine. I am a data scientist working on a hackathon platform called machinehack.com. Analytics India magazine is a premier media tech company operating in the space of data science and AI in India. Today, we are going to have a webinar about building deep learning applications for big data. The webinar will be delivered by Mr. Mukesh Gangadhar. Talking about Mr. Mukesh Gangadhar, he is the staff lead for Asia Pacific and Japan, part of the compute performance and developer products team at Intel. He's a staff architect for optimizing software applications on x86 platforms, especially on the cloud and AI platforms. He has around 18 years of industrial industry experience and holds a degree in computer science and engineering. So before I hand over the session to Mukesh, I have a small notice for everyone who is attending. All the questions will be taken at the end of the webinar. We have allotted 15 minutes of special time for Q&A. If you have any questions, kindly type them into the Q&A section. I would appreciate if you avoid directly messaging the instructor during the webinar. We will take care that all the questions will be answered in the end. So before we start, we'll have two questions for you, two polls, and I'm launching the first poll now. And the first poll is, uh, are you a ML or a DL engineer? So what we mean is how much data deep learning do you use in your day-to-day work as opposed to traditional machine learning? So we are going to wait for 1 minute to have all of your answers. Okay, the results are in. We have 75% of the people have voted, and 64% of them work on traditional machine learning methods, whereas we have 36% of people who work in deep learning methods. So we are going to close the poll now. Thanks for your answers. It's very interesting. So we have the second poll that is coming up now. We would be happy if you answer that poll also. So the second question is that we are launching right now. What are some of the important features required to run deep learning workloads directly on a big data platform? And you will have your options which are integrated with big data ecosystem. So this is an important feature. The second important feature is scale out. The third one is fault tolerance. The fourth one is elasticity, and the fifth one is incremental scaling. So we have good amount of votes coming in. I would request everyone to please vote. We have so it is good insight for everyone who is attending the webinar, and the presenter will also tweak his messaging and instructions for you accordingly. So we are keeping the poll only for 15 more seconds, and we'll stop voting after that. I'd request everyone to kindly voice out your opinion, and we could start with the instruction. Okay, we are closing the poll now. Most of the attendees think that integration with a big data ecosystem is really, really important. So we are closing the poll now, and uh, you can see the results for yourself. It's very interesting. So thank you for voting and letting us know your opinions. Now I would like to hand over this mic and the stage to Mr. Mukesh. Mr. Mukesh, please start. The stage is yours.
Hey, thanks so much. Can folks hear me okay on the call? Let me know if you have trouble hearing me. And I apologize in advance. I do have a slightly bad cold, so in case I end up coughing, so sorry about that. Okay, so let's get started. I think we are pretty much 10 minutes into the hour itself. So what I'll be talking about is going to give you at least introduction in terms of how one can introduce or take advantage of building deep learning models within a big data ecosystem. And I have been working in this space for quite some time. I've seen challenges where people are already have an existing some machine learning platform. They're already running models of different capabilities, trying to address their concerns, product concerns, or their customer concerns at the end of the day. And at the same time, they would want to take advantage of the newer advances that are made in deep learning. And they always want to look at an easy way by which both these two disciplines can essentially be merged together in a fashion that they will be able to take full advantage of it. So I'll give you one such approach today. There are other approaches possible, but possible we can discuss one such approach today. And I'll also indicate where you can get additional material, so that you can probably do your own research, or if you want to play around with probably reference implementations, use cases, and things like that. And also, if you want to, feel free to contribute as well in some of these projects that I'm going to talk about, right? Okay, let's get started. The theme, as you know, is as was already been introduced. So, but my okay, somehow my screen's not moving forward. Okay, all right. So today, in general, I'll be talking about two very specific areas. One area is called as Big Deal. It's trying to bring deep learning support into a big data framework as the key point has that's being highlighted out here. If people who have done or at least read about deep learning or done some activity around deep learning, you'll find that the software stack that predominantly people use, don't have any direct relation to the big data stacks out there. So you essentially have two parallel stacks, right? So you have the Hadoop and the Spark ecosystem in one area. The second area is you have the TensorFlow, Cafe, MXNet, PyTorch kind of frameworks. And for you to marry both of them in a more cohesive manner, it's not there are approaches people have attempted it in the past, but it's not an easy way. But I'll talk about one such software stack that does help you in this specific regard. The second aspect that I'll talk about is probably something called as a more of a unified platform. This is trying to make uh, production ready big data deep learning workflows, right? This is more targeted to that in that specific area. It talks about something called as unified analytics platform, and and how do you combine AI on top of that. Uh, how do you use frameworks like TensorFlow? You use the Keras like API, infrastructure, ML pipelines for Spark and things like that. So it's a combination of how do you integrate these components in a fashion that will allow people to explore, taking some of these learnings into production as well. So we'll try to at least provide a brief overview with the time slots that's been given to us, right? And feel free with your questions. We'll try our best to answer all of them in the call. If not, we'll try to figure out a way about how we can provide feedback on all the questions and clarifications that you guys have. Okay, so the kind of motivation behind Intel to look at this particular aspect is predominantly in a couple of areas, right? One is probably, I think, something that you have seen repeated in many talks. It's talks. This is this kind of a shared by one of the torchbearers in the present deep learning world. His name is Professor Andrew Ng. He's part of. He used to be Stanford. I think he also runs a popular online MOOC website called as Coursera. He's one of the co-founders of that as well, right? So he essentially talked about a very interesting analysis based on the work that he's been doing. Pretty much essentially saying that, hey, with the amount of data traditional machine learning algorithm saturates at a certain limit. But then when you start applying deep neural networks to the specific problem statement, or when you augment the machine learning pipelines with this, depending upon where you stand in terms of the complexity, whether you have small, medium, and large, as depending upon the growth in the data, then the performance here is talking more in terms of the accuracy of your model itself, right? It kind of increases. So he kind of he's been proving that. If I'm not wrong, or if I recall correctly, I think this was a talk that he gave when I think when he was, if I'm correct me if I'm wrong, I think he was when he was part of heading the Baidu AI lab. So I think there's some insights that he essentially shared. It became a very wonderful insight because it essentially showed the fact that as long as you have good, clean, large data sets, kind of which also are where you have the ability to label them as well. Any kind of any supervised learning tasks at the end of the day, as you increase the complexity of your neural networks and you're able to get your neural networks to converge, then the accuracy of your neural network essentially increases as your data set grows as well. So this became a very interesting insight, because considering every industry that I know is essentially looking at increased growth in terms of data. Now all we need to ensure is the fact that as long as we have good access to clean labeled data, and then we should be able to apply some of these deep learning approaches that people are identifying and working today to come up with interesting solutions and answers. Second aspect is trend two. This is mainly coming from the traditional big data fields. Right. So, and it's not necessarily to do with Hadoop per se. I think it's more to I think the idea behind this particular aspect was to talk about how the Hadoop ecosystem, which includes all its the new derivatives like Spark and Kafka, Storm, Flink. You talk about your document stores, all the new kids in the block, right? And in terms of the traditional cloud stacks that you're well aware and use in popular solutions today, all of them essentially have become kind of taken for granted, right? So if with today's solution that many people that they want to develop, They essentially try to look at, hey, can I take advantage of existing software stacks that are available out there? And you would essentially start picking up names, and probably the names were, some of the names that I essentially talked about would already be in at least in the minds and decisions of many of the folks in on the call today as well, right? So it kind of becoming the center of data gravity is I think one of the trends that we essentially wanted to point out at the end of the slide. And the third trend essentially comes out as this is a paper that came out by, it's a kind of a slight dated paper in 2015, but the insights that this paper gave out is still relevant today, right? If you're actually talking about trying to take advantage of deep learning models within big data stacks and things like that, it's all about, not about hey, I have some it's not like I have a new kid in the block, let me try to figure out how to learn and probably try to see if I can implement it. But there's a real use case at the end of the day that I already have an existing big data stack out there, which is probably running in production now without disrupting the my actual production scenario. Can I essentially augment whatever I'm running today? So that's a big and a huge challenge that many of the customers that I talk to are dealing with. And this was kind of echoed by this specific paper. This was given by, I think, highlighted by even, I think, one of the Google fellows, I think Jeff Dean, right? If I'm not wrong, I think one of the initial authors that essentially drove Yahoo to create the open source Hadoop implementations as well. So he is, they essentially came up with this kind of study which essentially showed the little black box in between is essentially all your ML model, but what you have all these big boxes in different sorts of grayish colors is all the other ecosystem or all the other let's say components of a machine learning pipeline that is actually out there in deployment today, right? We are essentially focusing on an extremely small problem, but you need capability for feature extraction, you need ability to data collection, data verification, you need to do for massaging of data, you need to ensure the fact that the data is in the format that you would want. You want to have some sort of monitoring tools, you need infrastructure configuration, you have a whole bunch of plethora of software infrastructure that is essentially needed for any machine learning model to be essentially put in production today, right? And these components already exist. It's not the fact that something has to be created from scratch. Many of them actually exist, right? And this became very interesting. So if people have not read this particular article, I would highly recommend to do so, because this is probably something that will echo as we go along. And many people are trying to solve this in one form or the other, but it will take a concerted effort by the entire developer ecosystem to ensure the fact that this is actually smooth as AI gets adopted, increasingly gets adopted across every industry that we know. Okay. So this is continuing with the trend. Again, this is kind of highlighting in terms of how we would look at a unified platform. This is for many people who have been or who starting off in the space. This may not be may not be too surprising, but for a person like me who's been following and working in this area for quite some time, for this entire picture on the right hand side, the unified big data analytics platform to come into play has been a long process. And a lot of software stacks that have been created, many of them have not seen success, some of them have seen very good adoption and things like that. So this has been a maturity of the big data platform itself, right, as you go along, both for handling batch processing and for stream processing at the same time, right? So there's increasingly work that people are looking at, hey, I need to handle my ML platform needs to handle batch transactions at the same time streaming transactions, and I don't need to create separate clusters for both of them. Can I essentially use the same infrastructure to do so? So there is this good maturity or that's happening in terms of of developing this infrastructure in place. And and considering the fact that many of the developers are not just looking at probably developing in SQL or in Java. So they're essentially using different sort of tools. So you essentially need your most popular, either from a productivity standpoint. So you need support for the at least quite popular let's say languages like either Python or R or Java or even SQL, or interface mechanisms. It could be even something like a spreadsheet or Jupyter's and things like that. So there is a more from an interactivity standpoint, from capability standpoint. So we are actually seeing a very natural evolution of this particular analytics platform being built into place. And for people who actually have deployed this, and this should not be a surprise, because I think most of the components that we essentially would be seeing here would essentially being run in production as well at the end of the day. But this is the kind of challenges that we see. There is on the left hand side are the deep learning experts. These are guys who are essentially probably developing deep learning models for various use cases. It could be whether in let's say in the NLP area, it could be in text classification, it could be probably in medical imaging, and so on, depending upon which domain and vertical or industry that you're talking about. People are essentially building up deep learning models using various deep learning infrastructure components at the end of the day. But on the right hand side is your standard big data users, right? So these are the ones that are in production today. People essentially want to figure out, hey, how do I essentially take something on the left hand side and then implement it on the right hand side? So our whole talk is essentially trying to figure out how do we essentially bridge this chasm out there, right? And how do we, what kind of tools we have, what kind of capabilities that one needs to have to essentially ensure the fact that we are able to bridge the work that is being done by the deep learning experts and into actual production scenarios where the big data users are essentially leveraging them today. And in many cases probably that we have seen success. There are use cases that we can talk about. Whether let's say in terms of whether it's an online shopping experience, whether it is on let's say from sentiment analysis or sequence to sequence, from HPC standpoint for weather modeling. So think of it multiple ways where people have figured out ways by taking specific models that the experts have developed and integrating it with the big data stack on the right. So a quick overview of Big Deal. This is kind of trying to treat Big Deal as another library within the overall Apache Spark ecosystem, right? And I'm sure that I don't have to introduce Apache Spark to the developers on the call today, but I'd just like to introduce the basic components of what's Big Deal. So it's essentially, think of it like almost like a yet another deep learning framework, or like TensorFlow and MXNet and PyTorch and things like that. But it's not it doesn't have any independent existence like those specific frameworks. This is very tightly integrated within the Apache Spark ecosystem as well. The interesting aspect that the architects essentially took when they created the Big Deal library was to ensure the fact that it's treated as a standard Spark program, right? So taking advantage of all the expertise that people have on writing Spark applications. We didn't want to change that particular approach, right? By introducing new let's say new ways by which you can to introduce deep learning applications, or to introduce deep learning models within your big data stacks. So it should be something that people are very well versed with. So we took a standard approach of saying that, hey, it should not have, there should be no specific change that people should undertake when writing big DL applications, right? And the other aspect that we took cognizant kind of an approach was ensuring the fact that we actually have parity with popular deep learning frameworks, right? So many of the people who essentially want to start off deep learning are already using deep learning. They're already using some of these stacks out there, right? Like FA-Torch or TensorFlow. Actually, it should be PyTorch these days. Should not be PyTorch. So they're already using this, right? And they already have started working, and many of the models that are actually available out there are primarily available on some of these deep learning frameworks. Now, if you want to integrate that into big deal, right, then we need to essentially ensure the fact that whatever model that we have built with TensorFlow, it should probably run on big deal as well, right? So we essentially provided a feature by which you have the ability to import, let's say, models that you may have already trained on Cafe or TensorFlow or PyTorch or MXNet and directly into big deal itself, thereby defeating the purpose of recreating the models in big deal, right? And also thereby improving productivity, right? So you don't have to figure out or scratch your head in terms of, hey, how do I essentially recreate this model in big deal? So as long as you have knowledge of how to write a a deep learning model on TensorFlow, or you already have access to a pre-trained model that either you're using or probably somewhere from the web, and you would want to integrate that within your big data stack, then you should be able to do so. So that is something that we have done. Second thing that we essentially looked at was, we wanted to figure out that you're running as efficient as possible on the underlying set of clusters, because you already have a cluster out there, right? You already are running your big data stacks on clusters out there, huge clusters, right? In many cases, it's probably in instances that we know, it's probably in many of the hundreds and thousands of nodes, right? At least the customers that we are aware of, right? So we wanted to ensure the fact that you're not leaving performance on the table, right? So many of in the Intel architectures out there have support for some of the basic computational operations that deep learning frameworks do today, right? So we try to leverage very popular libraries like the Intel Math Kernel Library. We take advantage of the large number of compute cores that are available on CPUs, so using multi-threaded programming. So all of that is essentially seamlessly hidden by big deal, right, at the end of the day. Right? And then the other aspect which we wanted to ensure was the fact that, hey, since remember, this is Spark doesn't run on a single platform, right? It actually runs on multiple nodes. It could be 2 nodes to all the way to probably thousands or 10,000s of nodes, right? And we needed to ensure the fact that there is an efficient scale out mechanism. So by taking advantage of the distributed framework that Spark already has, and augmenting that in a fashion that we'll be able to support for deep learning at the end of the day. So we also looked at trying to ensure the fact that we should be able to leverage the Spark ecosystem to do distributed training and inference at the same point in time, right? So that's probably another added piece of advantage that we essentially brought into the big deal space. Now, before we go into the next slide, I just wanted to highlight that the big deal aspect is an open source product. Remember, in the start of the talk, I essentially mentioned the fact that there is probable areas by which you can either build your expertise on big deal. One is either leveraging use cases or understanding the use cases and things like that, or even contributing to big deal. So if you see an opportunity and if you see certain capabilities that you like to see in big deal, please go to the GitHub link that has been mentioned there. Either provide your path set, probably clone it, and you probably see if you want to add to it and things like that. It's a very actively maintained GitHub, so you should have some developers who are actually working in this space, probably either probably asking for more details about what is the patches and things like that. So you should have some good discussions happening with the developers at that point in time. But if you're not still that's not looking at that particular space and you just want to give it a try, just go ahead into this particular website. It does give you good examples, good use cases, so that you can start trying out and then play around with it and see how you can take advantage of this as you go along. Right, so this is probably getting a little bit more into the next level details. This is, even though remember I told you about the fact that the big deal program is supposed to run as standard Spark programs, right? And how do we achieve that, right? So almost what we essentially do is if you understand the Spark ecosystem or how Spark runs in a distributed fashion. So essentially have a Spark driver, which is running on one of the nodes, and then which essentially creates a whole bunch of workers. It could be a single worker per node, it could be multiple workers per node, depending upon how you configure your Spark instance at the end of the day. Right. So each worker essentially runs on its own JVM instance, and each where worker would be creating a Spark task, and within that you would essentially have your big DL library. The big DL library, depending upon each computation that it would do, it will figure out if it can take advantage of the Intel math kernel library and so on and so forth. Right. So in terms of deep learning, the way it becomes as a standard iterative process. So each iteration, of the training would run as a Spark job itself at the end of the day, right? So, and each worker would be running as on an independent subset of data. So it's almost like independent batch. Let's say, for example, here I'm running. I want to do, let's say, training on 32 images. So probably worker 0 would be operating on 32 images. Worker 1 would be operating on an independent, 30 next set of 32 images, so on and so forth. And after each iteration, you would essentially, as any standard, deep learning framework, you would actually have to, synchronize. So you do your, so that you use your something like a stochastic gradient optimizer at the end of the day. Then, Big DL does support a variant of it so that it is more, let's say, it's a SDD that is more suited to the Spark framework at the end of the day. So we take advantage of that. We sync up all the multiple workers that weights and biases of all the of all the workers that was executed for one iteration. We sync them up, redistribute them, and so that when the next iteration starts off, there you have a new updated weights and biases, and it spreads across all the workers depending upon the number of workers that are running, and depending at that essentially boils into the number of iterations that you're doing. So this approach is something that that is very similar, very familiar to how deep learning frameworks run today. We have tried to ensure the fact that we follow the similar methodology, all sticking within inside the Spark framework from an execution standpoint. Okay, so remember the when we talked about the unified data platform, it's a data scientist at the end of the day is not expected to let's say know just one specific language. They may be more comfortable in R, in SQL, in Python, and so on and so forth. This is probably a way by which you can take advantage of how we are essentially integrated, or taking advantage of Spark SQL, probably DataFrames, and then using user-defined functions within Big DL, so that you should be able to do some sort of classification. Let's say on the left-hand side is you have a database which is probably sitting in a HDFS, or some data store or data lake at the end of the day, and you would want to do some sort of a classification of let's say in this toy example, it's probably classification of all dogs at the end of the day, right? So what you essentially see in the middle is sort of a SQL query that all you essentially looking at. Okay, you essentially load the entire data into a data frame. You select all the images, and then you run a big DL user defined function, which essentially does the classification for you, or using the big DL framework. And then all you have to do is essentially filter it by doc type at the end of the day. So for people who essentially use SQL, this becomes extremely simple, because they, again, to them at the end of the day, all they are essentially using is SQL like interfaces, SQL like capabilities, without being exposed too much into what big DL is, how do I use big DL, how do I use deep learning, and all those things like that, right? And it's all hidden in this user defined function at the end of the day. And this becomes simple as you can today maybe not, at least from a streaming standpoint, I can essentially apply different sorts of SQL queries, and then apply very simple UDFs at the end of the day, and I can probably provide very seamless connectivity between my big data stacks and deep learning frameworks at the end of the day. Going forward, it's again this is this kind of a different way of looking at it. If I want to see if how I can take advantage of it from a Spark streaming standpoint, I have a different sort of data ingestion that's happening from different
SaaS stacks. It could be from Kafka, Flume, S3, Twitter, wherever it is. I'm streaming it through my Spark streaming APIs, writing all of them into RRDs. Then I do essentially have my big DL model where I essentially am training it using batches, and then I'm using streaming for predicting. Then I use an evaluator, and then I use a stream writer. So it's all I essentially have to do is if it will take a look at it, most of the components that are essentially are in use today, I'm essentially replacing probably a traditional ML task with probably a big DL model at the end of the day. So that's probably a big change that you can look at. And beyond that, it's nothing new for many of the folks out there. This Spark ML is a new project, kind of actually new, not new. It's probably around, maybe if I'm not wrong, a year and a half old. A project from Databricks of trying to if trying to bring more seamless connectivity between from all the way from data ingestion. Can I do augmentation? How do I do estimation and classification? So there is a very simplified pipeline based approach, and ML pipelines is one very simple API that tries to achieve this kind of a simplification at the end of the day, right? So it's something that it's kind of a new kid, but it's something that's gaining extreme popularity with at least some of the customers that we have worked with. TensorBoard, if people are not aware of it, is essentially is a tool that is part of the TensorFlow environment. It is used for visualizing how your deep learning, machine learning models are either converging, how are the statistics, how is the behavior of my model and things like that, either as you train along or as you predict. So it's a very nice visualization API, or sorry, visual API. It's actually a UI. Big deal is essentially taking advantage of TensorBoard. So if you want to visualize how your model is behaving, both from a training standpoint or from an inference standpoint, I think it would be this visualization tool actually gives you very good insight. And we are taking advantage of all the existing tools that is actually out there. So if you want more information, then there is this link that's actually been provided. I think you would please to take a look at it for more details. I think this is probably the biggest ask that we had from customers. I think it's great to see that we are actually that the architects of the big deal framework decided not to either drop it, but actually increasingly support it even more than this. We just started from TensorFlow, Keras, Cafe, I think PyTorch. I think there's also support for ONNI and things like that. So it's very interesting. I'll take you through a couple of these things on how useful it becomes. In a way, it gives you you know a clean separation between people who are essentially building models and people who are essentially deploying the models at the end of the day, right? So the data scientists at the end of the day can essentially use the standard deep learning frameworks, but when it goes into production, right, and if you already have a big data stacks, then there is this big deal approach that essentially gives a very easy approach for people to use take advantage of that. So it gives you a very clean separation between your data scientist and the production engineers at the end of the day. The interesting aspect that I found when I used Big Deal is essentially for model fine tuning, right? So model fine tuning is an approach where I already take a pre-trained model. When I take a pre-trained deep learning model, it's already been trained on a specific data set. Now I want to fine tune this specific model to my own data set, right? My custom data set, rather than retrain the entire model from scratch, which is probably going to take a long time. Can I essentially do fine tuning of the existing model? Right? So big deal allows you to do that. It allows you to do fine tuning. So thereby let's say I'm just throwing an example here, right? So let's say I'm using YOLO v3 or probably SSDs for object detection, right? And I have trained SSDs probably on ImageNet dataset, right, for whatever purpose, right? But the data set that I have is probably for let's say it's like let's say, for example, for a product catalog of shoes. Right now I essentially want to take the same pre-trained model and I want to ensure the fact that the model that I essentially give, rather than giving me probability of dogs and cats, I want to essentially ensure the fact that it gives me various classification of different categories of shoes, right? I can essentially do that with fine tuning, right? And BigDL gives you a great way by which we can take advantage of that. Right, so that was a quick introduction to BigDL. As I highly said, if you want to learn more about it, please go look into the BigDL website that I just talked about. I think I'll just pause here for a second. I
Hi.
think there are a couple of questions that are essentially coming up. Just give me a second.
Yeah. Thanks, Mukesh,
Okay.
pausing a bit. So here we are launching a quick poll. We are only on for like 30 seconds now. So the poll is, what according to you is the key feature Analytic Zoo offers to users? So there are four options that you get to select from. There are built-in algorithms and models, feature engineering, a high-level pipeline APIs, or runtime environment. So we are going to wait for just 15 more seconds and we are going to end the poll. Okay, we are closing this poll now. So a good number of people are saying that built-in algorithms and models are really good while working with Analytics Zoo, and they also believe that high-level pipeline APIs are also good. So that is really great to know. We have one more poll question coming up very quickly for 30 seconds, and it is, what is the evaluation criteria for choosing any deep learning framework if you want to train on? So the options are availability of pre-trained models, pre-trained models, or support for neural network architectures. So we have good number of opinions on this one, and we are on for just 10 more seconds. Okay, so we are closing the poll now, and the results again are in. So 64% of the attendees think that support for neural network architecture is really important for choosing a deep learning framework. Okay, thanks for your participation. We'll continue with the talk. Please, Mukesh, please carry on.
Okay. Thanks, guys. So let's probably go to the next phase. I think we have limited amount of time. Let's see how much I can cover. Okay, so this is Analytic Zoo. So this is a new open source project from Intel. Again, you can take a look at this particular website that's been listed below. Both of them essentially points you to the same link at the end of the day, right? So these are it's a slight difference from what I talked about from my previous at least talk on BigDL. That was more focusing on what the tool can do, what BigDL is, what it's capable of, and things like that. But this is more to do with how do I integrate it within my big data stack, right? Now if I want to do, let's say feature engineering, if I want to do feature transformations on image, text, and let's say time series or speech and things like that. So what kind of data augmentation capabilities that I have, right? What are high level pipeline APIs that are available, right? And how do I do that, and what are the use cases that I have? It's great to talk about all these capabilities, but are there reference use cases, right? Many of the use cases that are actually listed on the Analytics Zoo are actual customer use cases, right? We have taken let's say work that we have done with many of our customers across the world, and we have kind of tried it out on many open source data sets that are available, and try to create a more generic reference use case that people can essentially look at and see if you can adopt it within the solutions that you are looking at, right? Or if you feel that there is something lacking in this place, please feel free and go ahead and probably even contribute as well to this particular aspect, right? So this is probably what Analytics Zoo, it's kind of the goal of the Analytics Zoo at the end of the day is taking advantage of the big data stacks, taking advantage of standard AI frameworks that are available out there. How do I integrate them to ensure the fact that if people are looking at from a production standpoint, how easy can I make it at the end of the day? So that's what this particular project is all about, right? And of course, can I take advantage of existing backends, right? Can I take advantage of Spark, TensorFlow, BigDL, OpenVINO, MKLDN, etc. Right? So that seamlessly, without developers or the data scientists or anyone trying to figure out, hey, should I use this? Should I use this? Blah and blah. But this kind of gives you, at least gets you started, right? Rather than spend time trying to figure out how do I integrate it, what do I do? This probably may give you a very quick start in terms of implementing some of these capabilities, right? Okay. Okay, so Analytic Zoo is very end, as I said, it's an end-to-end deep building. Actually, it's building deep learning applications. Right now, it does distributed TensorFlow on Spark. So we'll see how to do that. I think I do have some examples out there. If not, I think the GitHub link has got enough details about it that you can essentially look at. Keras is a very popular high-level deep learning. Can't call it as a framework, but this is more for improving productivity from that from a deep learning standpoint. Well, it was started supported for I think Torch and probably TensorFlow, but I think now it's even called CNTK as well, and Keras by default is what TensorFlow uses today, right? So Keras APIs are supposed kind of improves productivity from deep learning applications, hides a lot of mundane tasks that deep learning, at least framework architects were worrying about earlier, and we were offloading it to the developers, and developers were not comfortable about it. So Keras hit a lot of these capabilities. Then NN-frames, I'll talk about that in a little bit of while. It talks about how do I bring support for DataFrames and ML pipelines. It talks about built-in feature engineering operations for data pre-processing. Remember, in many of the slides earlier that I kept talking about was clean labeled data, right? And many of you who have been deploying big data applications, the fact that data is not exactly in a format that you would want. It has to be processed. It has to be, you have to analyze it, process it, remove all unwanted data. You have to transform the data into something before you actually deploy it in or take it into your big data stack itself, right? So there has to be some amount of effort that you would have to do in data pre-processing, right? So there are certain built-in feature engineering operations for augmenting that particular capability, and that is what Analytic Zoo also provides this capability. Then beyond that, it talks about like when I'm talking about model serving, right? Typically, when after I have trained a model, right, and I want to deploy it from an inference standpoint, right, then I may want to deploy it as a web service API at the end of the day, right? This may be it's may be part of my cloud stack, right? So then how do I do that? So there are very simple Pojo Java model serving APIs that Analytic Zoo supports. If it's with and without OpenVINO, right? I'll talk about. I think I have a slide that talks about that as well. Then support for your standard web services, Spark, Flink. If I want to ingress and egress out of my streaming services, right? Whether out of my like my Storm or Flink or Kafka at the end of the day, then can I essentially have support for that as well? So it has got modules that essentially have support for all these capabilities at the end of the day. Right, and of course, out-of-box solutions, which I've highlighted, is built-in deep learning models and reference use cases. I think it definitely talks about that, right? So this is a very quick example, in terms of how distributed TensorFlow is done on Spark with Analytic Zoo. It's a very simple three-step process. The first step, you essentially use PySpark. Gives us the ability to have a common programming language both for Spark as well as for TensorFlow. So in this particular standpoint, all we essentially do is load the data frames into probably populate your RRDs using your standard PySpark infrastructure, and then you convert them into some sort of tensors, because you need to have TensorFlow works on the concept of tensor objects. TensorFlow, tensor object, so you need to convert your data frames into something very similar. So you need to have that particular capability as well. So those kind of API calls are already being supported by the the Analytic Zoo pipeline API itself, right? So all you need to do is just load the TF data set, and it should give you your a call from which is from underscore RRD that will convert this entire data set into something that TensorFlow can understand. On step number 2 is you essentially load TensorFlow. Here in this particular case, it's a dummy. It's actually LeanIt, which is probably used as an MNIST. Using probably for more from your OCR standpoint, right? So essentially, I can build any sort of a deep learning model that I want to at the end of the day, and I can use my standard TensorFlow model that probably your data scientists have built at the end of the day, right? So I can essentially take that, integrate it into my Spice Spark environment, and then my third step would be essentially to use my TF optimizer. Remember, most of my when I do distributed rather when I do training at that particular standpoint, after every iteration, I need to let's say sync, so that I can essentially sync the weights and biases of every iteration, so that I have updated my weights and biases before I continue to the next operation, and so on and so forth, right? So I need to use some sort of an optimizer at the end of the day, right? So in this particular case standpoint, the Analytic Zoo does provide a TF optimizer that you can essentially use. Here I'm using an Atom optimizer at the end of the day for this particular example. I can essentially I can inform the BigDL environment that I'm essentially using an Atom optimizer, and then all I have to do is just call optimizer.optimize, and bingo, that's it, right? So from a very simple, if you take a look at probably 15 to 20 lines in this particular case at least, or a 3-step process, I have essentially ensured the fact that I have taken advantage of Spark, I have taken advantage of TensorFlow, I have taken advantage of BigDL to ensure the fact to provide you some sort of a distributed learning capability at the end of the day, right? Now, this is all assuming the fact that I already have my Spark infrastructure installed, I already have my BigDL libraries already installed, my PySpark environment is up and running. That's it. So I really don't have to do anything else beyond that to ensure the fact that this particular model works at the end of the day, right? And this can be used as a very simple hello world example that if people are looking at taking advantage, and people have built a lot more complex models beyond that. You can beyond this, and the reference use cases definitely are a good indication in terms of how people have done it. Remember I talked about transfer learning or fine tuning. So in this is a very simple example. If you take in this case, I'm loading an existing cafe model. I'm removing the last few layers, if I'm not wrong, right? Here I am essentially removing I'm removing all the layers after pool 5, right? And I'm essentially saying that, hey, freeze the model, because this is all required by the deep learning frameworks, right? So I'm freezing up the model for something called as res4f, and I'm adding this appending a few more layers to this particular ResNet model, at the ResNet 50 model at the end of the day, right? So very simple. I already think about that. I already have a pre-trained model that that's been shared by my data scientist, or I have got it from either a public repository from somewhere, and I want to fine tune it for my data set. I want to fine tune it for my use case, and I just don't want to rebuild the entire thing. It is probably going to be a customized training or other model for my application stack. And the Analytics Zoo essentially gives you an ability to to redo a few layers here and there that you can use, and then take the same pre-trained model that I have, and then fine tune it so that it can access the data, fine tune it for the same custom data set at the end of the day, right? So it's a very simple 4-line approach that can essentially give you an ability to do so. The other aspect which I talked about is NN frames. NN frames is essentially providing remember, any deep learning model or any machine learning model, you need to do, remember, data pre-processing, data augmentation is something that is extremely key. And NN frames is an ability to do that, right? So it can come in any format. Data can come in any format. All I have to do is have a user-defined function which essentially gives you an ability to load my data into DataFrame and do some sort of transformation. I think in this case there are built-in feature engineering capabilities for converting it into. I can now, for let's say for example, for normalization, convert my image matrix to tensors. I can use standard OpenCV calls to, let's say if it's purely an image-based conversions, then I can use OpenCV calls to augment the data set. Let's say I want to convert it into gray, or black and white, or I want to crop it. I want to rotate. I want to shift. Whatever I can do, I can do a whole bunch of image transformations at the end. So a lot of built-in features that are available. Even though I'm talking about images out here, I think there is a lot of support for text as well, right? So there you can do tokenization. You can provide support for embeddings and things like that. So all those capabilities are already built into the Zoo framework at the end of the day, right? So the other aspect is as I said, for Keras based support. Keras is, as I talked about, is very popular in the deep learning field. It gives a very easy way to build models. So in this in the example out here that I talked about, is I'm building a sequential model. I'm just adding a convolution 2D layer followed by a max pooling layer, and then flattening it, and then adding a fully connected layer at the end of the day, and using an activation like softmax. So very simple. I have a three layer model out here, and it gives me very simple way by which I can essentially use a chain to build the model, and it's not only readable for many people, at the same time it is also understandable, right? So it gives a very easy ability. Keras does that. It's a Keras style API. Remember, it is not exactly Keras, but it's a Keras. We use a very similar approach of was what Keras provides, and so that people who have used or leveraged Keras before have it becomes very easy for them to use BigDL at the or Analytical Zoo at the end of the day as well. And then you can use your Spark ML pipeline. You can use your estimators. You can use estimator.fit depending upon what you have. I can use I can set my learning rate. I can, like, let's say for example, my hyperparameters, 0.03, batch size, epoch, and and all those things like that. I can use my estimator API to essentially feed it to my Spark ML pipeline, and then essentially call my estimator.fit depending on to the providing my data frame as my input, and then I can essentially feed it to my to some Spark ML pipeline at the end of the day. So there are already capabilities for which can uh, you know uh, you know think of it this way: like the Analytical Zoo provides APIs and calls, library support for things that are missing in the big data stack, right? Your Spark ML pipeline is already available. So can I essentially provide seamless connectivity between my, let's say for example, TensorFlow environment to my Spark ML pipeline? So the gaps that are missing is something that Analytical Zoo provides, for the developers at the end of the day. OpenVINO is another open source product from Intel, which is primarily targeted for computer vision and image processing. I think right now it also does a little bit for text as well. So it is a highly optimized for the underlying Intel product line for for AI. So if we have provided seamless connectivity from the Analytic Zoo standpoint itself, so you can essentially use, depending upon the kind of inference model that you want, you can essentially use zoo.pipeline.inference, import your inference model. You can use your load TFA of your TensorFlow environment code, and then you can essentially offload it to the OpenVINO, which will by default take you through all the optimized inference engines that are available for running inference workloads, right? So with one common environment, you can take advantage of multiple capabilities. This is a kind of a message that I want to kind of reiterate with Analytics Zoo at the end of the day. I think I have talked about. I just don't want to kind of repeat it. But this kind of gives you the ability to integrate, and now I can do streaming. I can, depending upon where I want to have my model zoo, I'm sorry, my BigDL model, I can essentially have them at multiple places within my streaming service, and then probably still support a lot of deep learning models at the end of the day. Right. So at the end of the day, it's about trying to make it more accessible. Remember, I talked about the goal of BigDL and Analytic Zoo is to kind of bridge the chasm between deep learning and big data stacks out there. So, and provide software and hardware infrastructure, or rather, let's say, provide software infrastructure and leverage the hardware infrastructure that's already available out there to provide the ability to build deep learning applications, and take advantage of existing software stacks, big data software stacks that are available, and and provide augment to the capabilities from both ends. That is the next ability that we are trying to at least satisfy in this particular standpoint. And of course, the third one would be to add missing components, something like the deep learning functionalities using BigDL, right? Some of these things that we essentially want to try to help address, and at least from these particular two open source products. Remember, I talked about the final, which talks about reference models, because I can talk about the great value add that these products or projects that are being brought into the market. But at the end of the day, if people would want to see use cases, the people want to see how they can take advantage of it. So these are a couple of examples of models that are already available out there on the Analytic Zoo. Please free to take a look at them, from the use cases like object detection, image classification, text classification, recommendation, anomaly detection, sequence to sequence. So there are a whole bunch of deep learning models within these use cases that have already been implemented. I think we will continue to add to that. Now, if you feel that, hey, there is something that you guys are using and you would love to see, we would love to hear from you. And or you can definitely go to the the big data forums out there, and you can definitely ask your questions, and you'll have some expert, someone actually coming in and then definitely talking, and at least providing feedback to your clarifications that are being raised there. Reference use cases, remember, these are real world use cases. These are not toy examples, right? They're examples that we have taken from our engagements with customers worldwide, and trained them on public data sets and have released them on as an open source reference use case that you can leverage. Let's say, for example, if you want to do time series anomaly detection on time series data, right? Here you go. These are good examples that you can start off with. You want to do fraud detection, let's say on financial data, or you want to do fraud detection on telecom data, or any sort of data set that you have at the end of the day. You can use this. Or if I want to even look at let's say leverage this for some other let's say a use case, or if you find that I want to use anomaly detection in let's say fault maintenance, right, or industrial fault, then I can definitely see if I can leverage these capabilities. So feel free to figure out if these use cases are kind of useful for you at the end of the day. And if there are interesting use cases that you see that, hey, how do I take advantage of it, please feel free to get in touch with us, and then we'll see how best we can support you guys on that particular front, right? And finally, I would want to say, even though I talked about Analytic Zoo for a lot of time, but my final pitch would be to please note down this link, document it, and and if possible, visit them. Visit this link as often as you can. It's a very actively maintained link. And you should be able to get a lot of information on and a lot of use cases as we work with customers, as we are able to convert many of these customer use cases into something that we can make it more generic. We will definitely keep releasing on this particular website. And as as we see more use cases, more examples that are coming out, we will definitely try to find a way by which we can come back and probably present it to the audience out here, and take it forward from there. And I think I am done. I'm sorry, I think I am slightly I think I slightly overshot my time, but if there are questions, I'll be more than happy to take them. If not, we can definitely sync up at a later point in time.
Thank you, Mukesh, for your session. It was really informative. We will just allocate 10 minutes for Q&A. We have a couple of questions already, and I would also request the people attending to sending their questions through the question and answer box. So one of the questions from Amanpreet Mukesh is, what is meant by native deep learning support for big data? Mukesh, can you hear me?
Actually, I was on mute. I was talking. I was on mute. Okay. All right. Uh, Samapreet, so when you talk about native, right? So okay, let me quickly go back to this, right? So blah 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 blah. Blah. Let's see. Okay, here we go. Right. So when I talk about native deep learning support, I essentially, so if you take a look at how deep learning is supported today, right? There is no real integration between my big data stacks and my deep learning, so deep learning environments today. So there are two different stacks today, right? The software stack for big data is very different from that of the software stack that is being used for deep learning today, right? There are approaches today where I have seen specific support coming in, let's say from a TensorFlow standpoint, right? So support for HDFS, support for Apache Ignite kind of data stores, more of from a data lake standpoint. But if I look today, if I want to, let's say, use deep learning today, right? I have to write my code in probably TensorFlow, right, which is its own independent software stack. And once I have a trained model in TensorFlow, right, now if I want to run it in production today, right, and I already have a Spark, let's say a Spark infrastructure, I already have a Hadoop infrastructure, right? Unless and until I find a way to essentially get the data from my existing Spark infrastructure, feed it into my TensorFlow model, and take the data and feed it back into my Spark infrastructure, right? So I'm essentially creating a loop which is not exactly cognizant with my existing Spark infrastructure, right? So it's kind of an independent operation, right? It's not exactly seamlessly integrated within my Spark infrastructure, right? So when I talk about providing native deep learning support, it's almost like saying that, hey, I'm giving you an ability to create and deploy deep learning models within the same infrastructure that the big data stacks are using today, right? You're not creating a separate entity and trying to figure out how do I essentially stitch both of them, right? So there is this effort that I think the Yahoo guys have, right? So Yahoo has open sourced, I think, TensorFlow on Spark, right? So the way they essentially do that is they also have a very similar Spark and a Spark worker infrastructure, but rather than within each and every Spark worker, what they essentially do is they actually call a TensorFlow runtime. So if I have let's say if I create 15 Spark workers, then I essentially have 15 Spark TensorFlow instances running at the same time, right? And how do I essentially communicate between Spark and TensorFlow? So I essentially use TensorFlow capabilities, right? I use feed underscore dict. I think this is right now, I think they may have upgraded to Q model, but they essentially use capabilities that they essentially egress out of Spark and then ingress into the TensorFlow environment using the capabilities of TensorFlow. So it's not exactly seamlessly connected, right? And it doesn't really scale very well, right? It's so when I talk about native, it's when I talk about native, it's almost like bringing seamless connectivity, or rather integration, not connectivity. Integration would be a more better word, between my existing Spark software infrastructure and my deep learning infrastructure, right? I hope that answers your question.
Mukesh, the second question
Okay.
comes from Mr. Balabhaskar. He says it was a great session, and he asks how we can use the pre-trained data sets and modify it to certain use cases like disease prediction and health of a patient, etc.
Mm-hmm. Mm-hmm. So, so I think here you can definitely look at this particular. I think there are. I think not. I'm not sure about the reference use cases, whether they actually support disease use cases, you can essentially use anomaly detection. Probably you can fine tune the anomaly detection for identifying anomalies within from a disease standpoint, or you can essentially, if it is an image based, then you can use object detection. You can probably add your own pre-trained model here. Let's say, for example, let's say um, uh, very popular in the medical imaging field is exception and UNet, right? Maybe what you are, that there's, those models may be missing in this particular standpoint. So can I essentially take a pre-trained model, then integrate it within BigDL? So that's probably something that maybe a missing component that we have not focused on, but something that is already available. So you can essentially take a look at how the built-in deep learning models for object detection have been implemented, and then you can essentially see if you can add additional topologies that are more specific from a domain standpoint, and then and see if you can add it to support the specific use cases that you're looking at. But you can use these models that are already available, use cases that are already available out there, and then try to see if you can extend it to the use cases that you would like.
Yes. Thank you, Mukesh, for the answer. One of the last questions is how to integrate Analytic Zoo with SAP
Mhm.
HANA.
Hmm. That's an interesting question. Ah. But I think you should see, as long as okay, so that's going to be a this one. In fact, I think as long as I think you, if you look at this particular standpoint, I have something that has been presented on the slide here. If as long as you have an ability to use some sort of either a web service, Tom or Flink and things like that, if as long as you're able to uh, you know uh, use these existing stacks, then you should be able to integrate between analytics zoo, or and SAP HANA infrastructure. Or the other aspect is if people are interested to contribute, you can essentially see how you can provide seamless integration into SAP HANA. I don't think we have encountered a use case where we have integrated SAP HANA to the BigDL environment. I think that's probably something that is missing. I can definitely take that as a feedback into the architects who are actually developing this particular product and see what they have to say. But if it is something that is interesting, then either there would be support that would be provided, or if you feel that there is something that you guys can help out, sure, please free and add it into this particular kitty. It's anyway it's an open source project, and we would love to have additional contributions at that point in time. But in the answer to your question is, if you have an ability to take advantage of any of the let's say ingestion data ingestion stacks that are already available out there, and I think that should be probably at least the current best way that I can essentially look at of integrating SAP HANA with the big data and the analytics zoo components.
Okay. Yeah. Thank you, Mukesh. It was a great session.